learn about linear regression, and also we'll be learning regarding the logistic regression. Okay, so what is this regression basically? Right, so this is a technique basically, right, that creates a relationship between a dependent variable and an independent variable. Right. So a dependent and an independent variable in the sense that, let's say that there is an equation x equals to 3y. So the x is a dependent variable that is dependent on y, and y is an independent variable, right? Because basis on the y you are going to get the x. So there are two kind of data, that can be a dependent one and that can be an independent one. So whenever in your data set, when you load any data set or when you work on any data set, you have two kind of features. One side, you collect all the features as an independent data set. Okay, sorry, dependent data set, and the other side you take as the independent data set, right? So there we come to understand regarding the linear regression, which is one of the kind from the supervised learning in the machine learning, right? So it is one of the criteria of the supervised learning, right? So what is linear regression, right? When you talk about linear regression, so this is one of the easiest statistical models in the machine learning. Okay, so it is used to show the relationship between a dependent and an independent variable. Okay, that's a very simple syntax, and the equation we use there is one, two, three, four, simply. Okay. All right. Sorry. So let's just write first what is a regression. Okay. So first we'll understand what is regression, like writing up the definition, just that simple things. So I say it's regression analysis is a form of predictive modeling technique, right? Uh, which you can say defines a relation between the dependent and independent variables, right? Dependent and independent variables. Just create a relationship between these two things particularly, right? Then you should understand actually that what are the types of the regression we have. So we do say that basically today we'll be discussing on linear and logistic, but still I'm just giving you that what are the types. So linear regression, logistic regression, sorry, I can say polynomial regression. There can be lasso regression. Lot of things are there, right? So we are discussing on the two major things today. It is linear and logistic. All right, linear and the logistic, and we'll also create the table between these things, right? The difference between the logistic and the linear regression is there. Any common time? Yeah, fine, right? So these are the two things to be discussed today, right? So before, like in the regression, when I say that there are dependent and independent variables, what are then dependent and independent variables, right? What exactly I mean to say regarding the dependent and the independent ones? So dependent, you can say, are the ones, right? Oh God, again. Right. So what you define the dependent and independent? How you define the independent and dependence? So what will be a dependent variable if I'm talking about the dependent one? So a dependent variable is a variable that actually we want to predict when in machine learning. These are the, you can say this is what we predict. What what you predict. That's it. Right? So dependent variable is what you predict. Are independent, these are the factors on which you want to predict your data. Got it, the points? So you can say dependent as this, okay, fine. Factors on which you predict the data. That's the two important thing, major thing, uh, as for the dependent and independent variables to be learned on. Okay. Now let me give you a basic. So basically, if you want to create a relationship between a dependent and independent variable, you need a term called as regression. That's it, right? And these are continuous in the nature. Like you see a graph, you see a graph that is like an equation. Y is equals to, where should I write? Okay, this. So there is simple, you can say, equation right? For any simple factor, single factor, what we do in the linear, you might have started, right? This equation y is equals to mx plus c, a straight line equation, right? That is one kind of thing, right? So here what happens, here we deal with, right, let me draw these things, we're getting it better. Okay, now let's say we have a graph. Where is this draw lines? Yeah, so drawing is not like quite good, but still, let's say these are my points, these are x, these are y. Okay, and what I have to do is, let's say these are some of the data points I'm having. If you see the last session, we made a graph over there, a pair plot. There we find one straight line passing through the points, right? That point exactly is the regression line. So here we'll be passing one line that will be reducing the distance between this point to this point, right? So we want to predict such a line that could pass through all the points, that would come and reduce the like distance between this. That is called as error, reducing these things, distances. So from every point it should reduce the distance. That particular point will be called as a regression line. Okay, so in that area we have an equation, that is y equals to we generally say as alpha I plus alpha I xi. Okay, now what are alpha I and xi here? How do we define this? Alpha I is called as your regression coefficient, and we'll be finding out these things, coefficient. This xi, this one will, xi will be called as your independent variable, and this y, sorry, this y is going to be your dependent, right? Because on basis of this xi you are going to define this y, right? So that is the case. Okay, right. So simply you just draw a graph and you plot some data points, and there it goes with this. Okay, that's it in the case of a linear regression. Now when we come in the logistic regression, see what happens, that in linear regression, as I say, that the values or the graph you will be seeing there is a continuous graph. That means there will be a graph like this, which would go straight like this, or from here, or like in the downwards, anywhere. Like it will be going in a continuous state, whether if it is coming downwards or like going upwards, anything. But in the case of a logistic regression, what happens? We use this regression particularly when we are going for any categorical value, any probability things, right? Either this is true or false, success of various, yes or no, right? So there the points lies only within 0 and 1. That's it. So let's like think that if you have points something like this, again the same thing. Can you make any such point that will come go between 0 to 1 and cover all the points? No, right? So in that case what we can, because these can be a far distance from the actual one, right? So what we do here, we create a graph that called as a sigmoid graph or sigmoid function. So this goes something like this. So it tries to cover all the points between this area, like this. And we make one threshold, and that is automatically set. If you want, you can set your own thresholds. By default, it is automatically set. Now what happens, let's say you are taking some points from 0 to 10, right? So, one second. So you are taking points from 0 to 10. Let's say you took 0, 1, or you said that after 5, whatever the values would be coming will be going to 1. And below 5 values will be coming in the 0. So let's say if the point is 3.5 or 5.3, where it should go? It should not lie somewhere else or somewhere there, this, right? It should directly go to this 1. That's what. If the point is like 3.4, where it should go? It should go in the 0, 1. That's it. Like how the logistic will be running on, right? Okay. So here your equation changes, right? Here your equation changes. Here your like sigmoid function equation. What is that? P is equals to 1 by 1 plus e to the power of minus y. That's a sigmoid function, right? Or logistic regression equation would be like termed as 1 by this 1 plus e minus to the power of, right, alpha 0, alpha 1, x1, alpha 2, x2, all the features, coefficients and all, right? Don't worry, you'll be getting all the PPTs in your drive regarding all every type of regressions and all. Okay, for that you don't have to take worry. Alright, that's the kind of a thing I'm saying here. Okay, now let's say, like, let's make a graph. We'll get it better understood there. Okay, let's make points and let's create a graph. How actual points looks like, right? Okay, we'll discuss now. Let's take A as no, that is continuous. Okay. So let these be the y, or let these could be the y on the basis of fine. Three point five, 4.6, 5.1, 5.3, 7, let's take. What is this? Six point one. Fine. Okay. So Let's plot this x versus the y. Let's say this as it will be going with a straight line basically. So, okay, fine. Now, see, predicted value can be same or either cannot be same, right? So, what do we say that z equals to? Let's copy this, right? I'm just showing you a graph that how it looks like. So it can be same, it cannot be same. Sometimes it could be like less, or sometimes it could be more. 3.5, but it would be continuous one. Should be just keep on growing and growing and like that. Just change some values. Okay, let keep the same thing. So what you can see here is like points given up there, right? And this line is going with all through these points. What we have to do is we have to create one such line which should pass through all these points, right? And to reduce the errors, one straight line that pass through this, right? Continuous line. So we'll go through that, how we make infinite possible values over there, right? Okay. So first, I'm going to create a table, right? There we can distinguish what are their difference in the logistic and in the linear regression. Okay. So there will be a graph. One second. There could be a graph between those things, right? So let's make the dictionary of this comparison. Okay, and the comparison now will let you know, right, on the basis. So on that basis, we'll say like what are the features on the basis of which we are going to distinguish them, right? So I'm going to distinguish between their core concepts, the use cases, like let's say used with, how the values are predicted, finding the accuracy, because every model will be like taken as for one kind of predicted value, right? So it should be taken like for an accuracy test, like what is your model test, right? How much correct predicted values this is giving, what is the precision, right? That kind of things. If the value is 0.5, then is it 0.4 or 0.3 or 0.6? Is it nearest to what? Like it should not give like 1.5, 1.2. It can be nearest to 0.5, like 0.6, zero point 0.4, zero point 0.3, 0.004. No, I'm sorry, 0.45. Anything could be there. but not like 1. If it is crossing this 0.7 or 0.8 even, right, that is not a good model. So there can be some accuracy kind of thing through which we measure, right? So first compare the linear regression. So in linear regression, the core concept is that the data is modeled using a straight line. Okay. Now, next one. The next thing that is used with a continuous variable. Okay. You'll find all these things in your drive. Don't worry. Next, we have the prediction. So in linear regression, we predict actually the value of the variable, right? We predict actually the value of the variable, because what we have to predict, whether what is the value of y or something like that, right? In case of a linear regression, okay. And the methods we use to find the accuracy and or is like we can use uh, mm, by finding the loss or finding the r square means, or you say adjusted r squared. There are a lot of things, right, etc. Let's write. Yeah. Okay. So these are the logistic linear regression. Now let's come to the logistic part. I'll also show you the equation of logistic, how it works. So here the core concept is that data is modeled using not a straight line. There is the, so data plots on a sigmoid graph function, you say. Next. The next is used with again. So here we don't go for the continuous variable. Here we go for a categorical value. Because with that feature only we are going to get uh, all those things, right? That is the success or the failures, 1, 0, true, false, yes, no, and all those values, right, kind of thing. So the prediction here we do is not the value of the variable. Here we go for the probability. That what is the probability that the people survived, or like what is the probability of coming head or tail kind of thing. There what you do is you go for a success or a failure basically. And the last thing, that how we measure here. So here we have particularly a function called as accuracy. Here we have confusion matrix. Here we have what is that? Precision. Right, a lot of things similar to this are there. So this is the three parameters, like 4 parameters on the basis of which we are going to distinguish them. Okay, so linear regression and all these things, right? Let's run this. So That's fine now. Okay, yeah. So see, like on the basis of core concepts, in the linear regression, you plot the data on a straight line. In logistic regression, you go for plotting data on sigmoid graphs. Use this and all right. Okay, fine. So how a logistic regression equation looks like? So what I said in the case of a logistic regression, higher equation looks like 1 by e to the power of minus y. 1 by 1 plus e to the power of minus y basically. That is EQ of say p is equals to 1 by 1 plus. Yeah. So this is the equation, sigmoid function that belongs like p is equals to 1 by 1 plus e to the power of minus y, right? Where this you say like briefing it like in the below one, we'll be getting it better. In the linear regression, how it looks like, right? So what in the case of a linear regression? Okay, so in linear regression, what comes? Y equals to alpha naught, beta naught, like whatever you say, right? Beta naught, beta 1 x1, beta 2 x2, right? There can be several features. When you talk about a data set, what are these columns called as? These are actual our features. When we'll be loading our data set, we'll be looking on there could be various features in the regression. Okay, there can be a various features in the regression. 1 minute, let me join. Students are coming up. Right. So let's define all the features and whatever there it is in the linear regression, how we go through all those things, right? So there are several kind of thing like parameters and errors. What are there in the linear regression? There are two kind of thing. One is simple linear regression and the multiple linear regression. Okay. So in simple regression, what happens? Only one independent variable is used to estimate a dependent variable. All right. Let's wait for 4 or 5 minutes. Other students are also coming. We'll brief it once. Okay. Till then, we'll write the equation of a linear regression, how exactly it looks like. Okay. So linear regression equation would be that would be I think this would work. One exponential is missing. This is the random ones. Alright, that is fine. Mention it again. So we can see it as beta x plus, can it be xo x0? No, that can be multiplied with those and alright. Okay, so let it be beta x, and similar to there could be beta beta I1, I2, I3, and such like things. Okay, so I'm using, in case of I and all, what I'm going to use is like this is beta, or you say this is beta naught, right? Someone is there. So particularly, basically, the equation something like as y will be equals to this beta naught plus this beta 1 plus one feature plus beta 2 plus another feature plus beta 3 plus another feature, and it will be continued till the end of these features and their coefficients. Now what are these things? I'll discuss, right? Let them join quickly. Right. So what happens that in the linear regression, all right, so those who have joined now, we are going to discuss the linear regression and logistic regression today, right? One of the kind of the machine learning. Okay, we're going to discuss those things, right? Okay, fine. So we'll be starting from this linear regression concepts. We have discussed something you'll be getting in the videos, right? That contains. We are going to start up with the things, right? Hmm. So when we understand the regression analysis, what I say that this is a kind of an analysis technique, predictive modeling technique, through which we make models, right? And we create a relationship between a dependent and an independent variable. Okay. Now let's talk about the graphs. I think it should be there actually. It may be in my drive. 1 minute. So where it is, modeling techniques and writing July. No. Day 2, supervised regression linear. Okay, fine. So we'll update the another PT basically. This is not the one what I am searching. Options. What we said? Linear regression. Yeah, that's the problem. Where's my card? 1 minute. The card is skipped. Okay, fine. Is this given up the things? Fine. Okay, this is what I was searching. So possibly there. And let's come back to this. Yeah, fine. Okay. So let's understand the thing from the starting. So what is regression? An analysis or a predictive modeling technique which investigates the relationship between a dependent and an independent variable. Now, when we talk about dependent and independent variable, as I said again that let's say this to be black, right? So let's say an equation that is like x equals to 3 plus y, right? So in this particular equation, can we say that this y is going to be something called as dependent and this x is something which is independent? Sorry, this x is independent and this y is to be called as independent, right? Because on the values of y we are going to write the values of x. Until and unless you don't know the values of y, how could you write the values of x? So x is ultimately dependent on to y, right? So what is there? Right? So this is dependent on this y. So this x, which is a dependent variable, is dependent on y, that is an independent variable. So what this regression does, this creates a relationship between this independent variable and this dependent variable to find out, right, what is the value of this y, and there must be one coefficient. So you must have known about the straight line equation that comes like y equals mx plus c. This equation, y equals mx plus c, right? Okay. Moving next. So where these things are used, the three major use regression analysis, right? We go for stock predictions, we go for forecasting any effect, right? Searching for this thing. These are the use cases of the regressions. Okay. Now we have seen this graph, like on the basis of the core concept, we say that in the linear regression, the data is modeled using a straight line. Straight line in the sense that there will be one graph and it should be continuous in the nature, like it should go like this, one, or like any straight line would be there. It's starting from here or here, whatever it is, right? And these are continuous variables, where in the case of a logistic regression, there we use the probability features, right? We use the probability of any obtained event. It can be like in the linear regression, what you do, you find the values. In the logistic regression, you find the probability. For understanding, let's say that you want, you have a question, right? You have a question and you ask that in logistic regression, you can ask what is the probability that there could be rain tomorrow or not? Rain possible or not possible, right? That can be a question. Okay. And in the linear regression, you can ask that for how many days there are going to be rain. The rain is going to be there, right? For how many days there is going to be raining, right? So this could give you a value, and this is going to give you a probability. That's it. The major important thing is to be understood right here, right? In the linear regression, you are going to get a value, and in the logistic, you are going to get a probability, right? That can be when you want your answer in case of like yes or no, when you want your answer in like true or false something, when you want your answer as in some uh, success or failures, in those features. When we talk about those things, we say they we use logistic. And when we want to find some, like we have an equation y equals to mx plus c, what we do, we find the values of c and m. If we know the value of c and m, so anyone who gives the value of x will definitely would be able to give the values of y. So there we find the values, and here we find the probability. Okay, so what is a probability like? You can't use regression in some logistic cases, right? Why? Because we'll see in practical what is the difference between like when we use some linear regression in logistic cases, what will happen, and what will happen when we use logistic and linear regression, what happens. Okay, all right. So here we find the accuracy by the loss, right? There is one loss, means that there you are going to create a regression line, and let's say your points will be here, so your main goal will be reducing this error, that is called as a loss. Okay, you can find r square, and all this have various equations we'll go through, right? So here you have categorical value, here you have continuous value, and here you find the accuracy of any model by precision, accuracy, ROC, confusion matrix, a lot of things are there. Okay, so there are selection techniques will go in that, right? So where is linear regression used? Again, evaluating trends and sale estimates, analyzing the impact of price changes, assessment of risk in financial services and insurance domains, right? A lot more are there. Okay, so let's understand now. Let's say you have plotted the two, like one graph, right? That is versus of independent versus a dependent one, right? This is your y side, this is your x side. Now let's say that my y is increasing, right? I say that I made a just a line over there right now. Okay, so that is like there could be some point of x and some point of y in this case, and that is giving you a line, right? This could be y comma x, sorry. Okay, so this could be like from here x and y, and I'm getting a line. This line is called the regression line. Okay, I will understand how. So let's say this is y, which is increasing as per the x, which is going to increase. Now again I'm saying that again I'm increasing the values of y, so does the x is increasing. So here I'll be getting a straight line graph that would be obviously positive because my x and y are accurately increasing, right? Similar to this, now if I say my x, right, let's see the condition y is increasing and x is decreasing here, right? In this case, I'll be getting a negative graph, right? So whatever the positive and negative we are getting, exactly this line is called the regression line, linear regression. Okay, now let's understand. Let's say this is one point, one data point, and who's there? Similar, we took another point, right? So these are the two observations, let's say. Similar, what we are going to do is we created just a graph over here right now. Here, like we took some data points over there, and that's like plotting up there. Okay, so let's take the points. So let's take more points, right? Let's draw a line and make some points over there. Now this line is called as a regression line. Okay, now you can use least square method basically to find the errors and all, like accuracy of a model. So what's our main goal is, like, let's say we have made a line and we say that there is a point. This is my predicted point p square, I say, right? So what is my main goal? My main goal is to find the error between this estimated value or the predicted point with this actual value, and that is the main goal for every point. So for the every point, our main goal is to minimize the error, to bring these points as much closer as we could bring, right? So that we could minimize the error. You remember in the last class we did pair plotting, where we saw various graphs, like 4 by 4 16 graphs over there, where we find a line that is being like very closely to all the data points, right? So you minimize the error over there, right? So let's discuss regarding the basic concept, like in the class 9th what we read, like speed versus distance. So let's say this is speed and distance, and increasing continuously will give you a positive relationship. Similarly, that is y equals mx plus c, right? And there this equals, what this equation means: distance traveled by a fixed duration of time, that is going to be defined over there, right? What is this x? This is the speed of the vehicle, right? And what is this line giving you? That is m, basically the slope of the line, right? And here we call the c as the y-intercept of the line. That's the basic concept, right? Now let's say that speed versus time, and this line is decreasing. Now let's say that is a negative relationship, and here we can say that the slope would be negative, obviously, right? So y will be equals to minus mx plus c, right? So same in the case of a dependent and independent variable. If you get a graph, this would be positive. Okay, so y is equals to mx plus c. This is the equation. What we get? A straight line equation. From here we say y has to be the dependent variable, this x to be the independent variable, and the c to be the intercept, right? Now let's understand regarding the data. Let's say this is x, which is 1 2 3 4 5. So well, let's plot this all: 0 1 2 3 4 5. Okay, similar to this, let's take y, that is 3 4 2 4 5. Okay, let's plot the y. Now let's plot the one. Okay, this is y, which is going to be a dependent variable on the basis of the x, and x is going to be an independent variable. Okay, now x is 1 and y is 3. That's the 1 point. Similar, we have 2 4, 3 2, 4 4, and 5 5, right? See the things: x is 1 2 3 4 5 and y is 3 4 2 4 5, right? If we again do these things, Here what you are getting, a line which is just going through like 1 with 3, where it is, x, oh, I have only plotted the values of x. So with the y it would be giving you, yeah, so these are the like points. With x1 this is equals as 3, with 2 it is 4, with 3 it is 2, is it so? Yeah. So this is the kind of a graph you're getting, like this, like a check mark. Let's see. Yeah, like a check mark. Okay. So this is a graph, right? Now, what we have to do is like we'll find the mean of this x first of all, right? So mean of the x will be 1 plus 2 plus 3 plus 4 plus 5 divided by the number of tens, right? That is going to be 3. So we'll pass a straight line with the 3 point 3, okay? Line 3 in the x-axis. Similar to the y, we'll find the mean that is going to be 3.6, okay? So we'll pass a line over there, right? From the 3.6. Now, we'll plot one point here. That is going to be the point, right? Nearest point. And from here we can pass a straight line. We can say it as a regression line. That's it. Like the concept behind this, how we draw the things, right? This is 3 by 3.6. And we say this is one of the such line where the all points will be, this is one such line where all the points will be very nearest. That is the best fit line, right? Now there are several features. There are several terms, how we say, okay? There are several formulas to find the values of the c and the x and all. So c is found using the formula of summation of y multiplied by the summation of x square, summation of x, summation of xy divided by n multiplied by summation of x square minus summation x whole square, right? Now for this we have to find the features. What is, like we have x and y. Now we have to find what is xy, what is x square, and what is x whole square, and what is this n belongs to, right? So let's go with this, right? So n is nothing but the number of rows. Number of rows. How many you have? 5. Okay. What is summation of y? 3 plus 4 plus 2 plus 4 plus 5, that is 18. Similar summation of x would be giving you 15, right? Now the term comes for the xy, x square, right? So we'll expand our table, pivot table, and we'll say the xy will be 1 multiplied by 3, 2 by 4, 8, 3 by 2, 6, 4, 4, 16, 5, 25, and so on, right? Similar, the x square will be 1, 1, 2, 4, 3, 9, 4, 16, and 5, 25, obviously, right? What about ex whole square? Ex whole square, summation of x whole square. What is summation of x? 15. And what will be the whole square value? Obviously, it would be going to be, if I say summation of x whole square would be 225. So this is the one equation. Oh God. This is the one equation. Where it is. Y equals mx plus c, which we have to fit on, right? So we have got all the points. Now what we are going to do is substitute that points to the values over there. So it is 18 multiplied 55 minus 15 multiplied 58 by 5 multiplied 55 minus 225. So here, from here we get c, that is equals to 120 by 50, that is equals to 2.4. So here we found that c is equals to 2.4, right? Now what the another thing is to find out the values of m. Now m formula is like summation of x multiplied by y minus this, all right? So with this formula we find the values of m, and we found it to be 0.28, right? You don't have to find out the things, right? You only pass the function, it will automatically calculate other things. You don't have to give the formulas and all, right? Okay. So here we have point x and y, xy and xy. So now let's say that if you have got the points, m and c, like m is 0.28 and your c is 2.4, right? So from here, if I give like after 5, if I give you points from 6 to 10, can you find the values for this? Can we find the values if we have 6, 7, 8, 9, 10? These the values of the x. Can we find the values for the y with this 6, like with this points, with this y, right? Can we find the values? So this is 0.28x plus 2.4. This would be the equation, y equals to 0.28x, that is m and c. And let's calculate for this. So C belongs to like from here we can see that this is going to be 4, 12, 15, 18, 20. Like values giving to be there 4, 12, 15, 18, 20. Let's see what comes. So when x is 6, y is coming as 10. When like it is 7, it is 12. When it is 8, it is 13.5. And it is 9, it is 17. And when it is 10, it is 20. If we see the next graph, like if we see the previous graph, we saw the points very closely. Like it is 13.5, it is 14, and like so our model is getting better, right? That is, our model is fine, right? Similar to this, we can make a lot of things basically. All right. So let's go with that, right? Let's create up the things. So in the linear regression, what you understood that dependent variable is continuous in nature, right? So to establish a relationship between a dependent and independent variable, we use linear regression, logistic regressions, and regression analysis is that's why used. Okay. So there in the linear regression we have simple linear regression and multiple linear regression. So simple linear regression goes with like y equals to mx plus c, right? M is your, like you can call many times you'd find it as y equals to alpha 1 x1 plus alpha naught plus alpha 1 x1. Alpha naught will be obviously you are going to be like c intercept, and alpha 1 would be alpha naught will be the y intercept, and alpha 1 would be the slope. In multiple regression, what happens? So in case of a multiple regression, you have actually the points. Let's say, so there what happens like in one it would be y equals mx plus c, linear simple linear regression, and in multiple linear regression it would be like y, and this could be equal to like let's say if you are going with the alpha or beta or anything, right? So let's say alpha 1 alpha naught, alpha 1 x1, alpha 2 x2. And what are these alpha basically? Right? Well, this is the y-intercept, right? Now let's talk about this all alpha 1, alpha 2, going with the features. Now these features are the values of the m basically, right? That are regression coefficient, right? That are being things over there. So how we make in a multiple linear regression, what happens when we talk about that there it goes with the multiple features. Multiple features in the sense like, let's say giving you an example that you want to predict the value of a company, you want to see that where your company is going to like if your manager is saying that they want to keep like invest some money on some companies, then how you are going to analyze which company is going to be the best, right? So what you are going to do, you are going to analyze that company on various features, right? You will be taking a lot of features for that company according to you, like what there is a need for you. So there will be a table which will be holding a lot of features. On basis of that we are going to say, okay, this is for this company, this is this is and all, right? So for the lot of features you'll have a lot of x values. But if I say that you have been given a marks, your roll number and marks, right? And you have been asked to predict whether the student passed or failed. It's very easy, because even if you don't have the roll number, directly with the marks you can say whether the student failed or passed. What you'll do is you'll make a graph over there and you'll make a threshold that this is 45. If the student got 45, then it will go to the 1, and if it is not 45, then it will go to the 0. That's it. So your graph goes in the sigmoid graph basically, like this, right? So if a student pass, the points come here. If it not pass, the point comes here. That's it. You can easily predict the values on one feature that is called as simple linear regression. Okay, so I think that's clear, right? So on the features, what you give the coefficient, right? So don't give a lot of coefficient basically, right? So that will make our overfitting basically. Overfitting in the sense like if you make not exactly like this. If you give your points to be very closely, if you say that you have given all the features, like if many time what happens like in the previous training, in one of my previous training, what happened, I gave one project of a movie recommendation, right? A machine learning movie recommendation project was there. So one student was doing it, like, and the data set were having 53 columns. So what he did, he passed all the 53 columns. as a feature. So what happens ultimately? This points goes over all the features, and the machine will not be able to understand which feature is important for your model, right? So when I talk about like the marks and the results, what is important in the roll numbers and the percent marks? What is important? Marks or roll number? Answer. What is important?
Mark.
Marks. Marks is important, right? Someone is saying something. Linear regression again once. Oh, okay. I'll summarize it this in the last, right? Because there are a lot of things to discuss now. We'll go. So what he did, he gave all the features, right? So it will be really very difficult for the machine to understand which feature is important. So if you give the right feature, the machine will give you the accurate results. Not very accurate, but okay, fine. That would be better, right? If you're getting even 60% of precision, that is fine, right? But if you're getting below 60, that is not good. So uh, if in the case of a marks or roll number or student name, what is like we have three features now, let's hope. Okay, and I'm saying that this is y, which is equals to like c. Okay, and then I'm saying that this is the marks feature, right? This is okay, let's say this is alpha 1 marks feature. Okay, let's understand as like marks features. mf I'm writing, it could be alpha 1 x1 x2 x3. Okay, then I'm saying alpha 2 roll number feature, alpha 3 what is that, student name feature. Okay, now let's say which feature value should I give more, right? I'll be having to give the values of alpha 1 alpha 2 and alpha 3. So if I give the values of alpha 1 alpha 2 and alpha 3, which feature I should give the value more percentage, which should I give the more to train on my model? Will the student,
Alpha 1 mark.
yeah, alpha 1 marks, right? I'll be giving it more percentage, right? As I will be saying 4.5, let's say my training data set 4.5% includes the marks, and let's say 1.2% goes with the roll number, right? And 0.3% goes with the student name, let's say. Right. How? So the more percentage or the weightage, we called it in this machine learning language, we call it that weightage. So the weightage defines what features importance you are giving. So if you are giving importance to the wrong feature, then obviously you are not going to get a good result, right? So that is important. When you give the correct weightage to the correct features, that is important. That is called as feature selection and all. You should understand which feature is going to be important for you for predicting your things. Okay, and the error, we called the error, we will getting the errors basically, right? That points, what you get there, where it is. Here also, like if this is a point, these are the points. If these are the points, then what are the things you are getting up there? Like if this is an actual point, right? If this is the point, we are saying that there is a point, right? So the distance between this is called as the error. That is the prediction value minus the original values. Okay, fine. That is all about the regression analysis basically. Hope that is clear to you. So there are a lot of features to be focused on, right? So there are training accuracy and all. Okay, let's go with the programming section now. Let's try to find up the things. Solutions. Okay. It's going to be concrete mathematics. see, like I'll be using summation feature to see how it works. Computes the summation of f with respect to all, like if I will be writing something like summation of psi, if I say with I equals 1 to n, right? So we'll be making it easier, like you can understand from here. All right, fine. Let's start. Okay, so going to the very first data set, I think I have here all those files. If I am correct now. LR2, and what is the next one? Titanic. Titanic, I think I have. Let's see. What's there? Excel, marks and results. So let's start with a simple linear regression first of all. We'll try to see like for the marks results and all. LR mark hyphen results result dot xlsx. Okay. Yeah, SLR is a kind of a weapon also. Yeah. Marks battery life it and what? Alright, I have uploaded a wrong one. 50 marks. Hmm. So simple linear regression, right? With the marks results, like if this is 53 and like So it is pass, 12 is fail, 11 is fail, 77 is pass, and these are the values basically, right? So first we'll look on that how many data we have. All right, 5,000 marks are there, and over 2 columns. That's nice, right? So how many has been passed from here? If marks dot result. All right. So 3,109 passing marks and 1,891 failure marks, right? Okay, fine. Now, so we'll be getting up like we have 5,000 marks over which something is failed, something is passed, right? That is nice. So what we have to do basically, we have to predict whether a person is pass or not. Whether a person is pass or not. But we have to see what are the points we would be getting up there accordingly, like with the pass and failures. So what I said when you talk about pass and fails, so there we need the discrete values. So pass belongs to 1, fail belongs to 0, right? So the very first thing is to create a dummy value for this pass and failures, right? The dummy values. How we'll be creating the dummy values? So the result is basically right. If I look onto my result, I'll see 1 and 0 over there. Now fail belongs to 0 and pass belongs to 1, right? If in the fail column, like if it is 0, that means it is pass. If it is 1, this is pass. So with only one column, I can understand whether the student is passed or fail. Like if it is 0, it is fail. Obviously, it is 1, it is pass. Then what I'm going to do is, we'll have to make our thing shorter, right? Why to make it larger? So drop first is equals to true. Now what happens? We only having one column, that is pass, and this will drop the first feature or the first column, you say, right? So the pass value says there's the first student passed, second student failed, third student failed, and so that's the thing. So see, all right. So let's make a see the head. So df of marks, or df, let's say, is equals to pd dot concatenate which data, df of marks with this df, with this result, and on which axis? 1. Look onto the head of df, and here you'll see the results, the pass. So now result feature is not important for us. Is this feature important for us? Like, are we going to predict something with the results? No, obviously not. So what we are going to do is, we are going to drop this, because that is not important for us now, right? Because on the basis of the past, we could understand the things. So we'll say from the df, drop result. And in place equals true. Okay, run this and you can see like marks and place. Okay, now so you can make predictions and all, right? But I'm just showing you a graph basically how it works. Okay, if I say graph of a regression plotting, and your features are the marks, pass, what do you see? the values from 0 to 1. Can you find the things? This is a straight line going through there, but it is not covering everything. You are getting only the points on the 0 and the 1, isn't it? Right? The points are only the 0 and 1. Even if you say that plt dot plot, or if I say marks and result to list, if you could see, marks would be all the marks right there. Same, the results would be there. Oh, sorry, that is result. 1 0 1 0 1 0 and all things would be there, right? So if you use a basic plotting, oh sorry, see from what you are going to find up there. The lines, basically, even if you write the things, right, these are so closely packed because you'll be getting a straight line over there, right? So things changes accordingly, right? This is a sigmoid graph, basically what you're getting. See, if you could see up the things, right? If you could find the values, you could see if there the values goes in the 1 and in the 0. Understood? So this is a graph of a logistic regression thing, where you predict the values, whether this is pass or whether this is fail. That is a case of a logistic regression. Okay, like I'm just showing you how it works. Okay, right. So let's come to the another data set. Now this is having a battery life, like a charge time over some minutes, and the battery life 24 minutes, 125 minutes, 43 minutes, 221 minutes, or understand is according, you keep it according to you. Like you think, like if it is like going to be charged for 43 hours, going to give a backup of 221 hours, whatever you think, you can go with that, right? So there are the charge time and there are the battery life. So if you simply plot a graph, before plotting, let's see that what is the shape, how many battery life and all, because that is important. Whenever you are going for training any data, you should have a good number of data for plotting even. Okay, so there we have 1000, fine, that's okay. Now let's see first the plotting of this. Oh, that is live. See what you are getting, a straight line going through there, right? This is just going through the straight line. If you say like in some dots, this will be obviously a straight line that will be going through there, right? That is same, and this will be same for every other graph you are going to see. Okay, right? So that is how we say. So what are the columns? Let's say, oh sorry, days, right? So I'm going to make this in the list. These are the columns, right? Now let's start our training feature, like selection feature, I say. So I'll be saying this X will be the charge time, right? Because on the basis of the charge time, I'm going to predict the value of Y. So this is going to be my independent data, independent feature, and the Y would be battery life. Right? These are the values of your X, and these are the values of your Y. Fine. Okay. So on the basis of this X, we are going to predict the battery life for the any new number. Okay. All right. It goes from 0.11, ends at 99.565. Now you have to bring that features and all what we are going to use here, right? So from the sklearn dot the linear model, I think there's an underscore, import the linear regression. Okay, that's the one thing we have to do, very first thing. All right, and here we don't going to, are we going to do with the selection techniques and all. So for the logistic, we are not going to use this. So let it be as it is. Okay. Yeah. So this is like importing the linear regression, right? Now make a model name, right? So let's say we are going with the battery life. So let it be BL battery life, right? So this is going to be linear regression. And I say that you don't have to write any formulas and also you just pass the function of the linear regression. Every module, every function, every formulas will be passed on this model, right? So whatever there is a requirement, it will take automatically. Now after making this, you fit the values of x and y to this model. That's it. Oh gosh, there is an error. Expected 2D got 1D. Alright, done. Right? Now we have to find the values of m and c, the slope and the y-intercept. So m would be your model name dot the coefficient, right? Slopes. And your c is going to be your model name dot the intercept. That's it. C, what is your m? 5.2527. This is the value of m. What is the value of c? This is the equation. So equation becomes to simplify LHS and RHS. Oh, what is this? M plus C is it giving us values? Oh, the equation is y equals 5.25x plus 2.26. Now, can we write any values of x to find the values of this? Right? We can write any values now to find the values of this. So, what's now to be find out, right? We are going to find the prediction, right? So, like if we write the model dot predict. So, what is to be predicted? Any charge time you write. So, let's say you write 102. So, see, even if in your charge time, remember, see, if you see your charge time, df dot charge time dot max df is live. This is 99. So maximum was 99.56 and I'm giving 102. So even if the data is not there, it is giving you a value based on that y. Right? Got it? That is like how we make the things. Now let's see the graph, how the graph looks like. So we'll make a quite big graph. Figure size 2160110 axis y what is the problem x and y to be the results. Okay, this is equating other things. X and y is the problem. Y is a series, x is the like value, so there are a lot of x and y. Yep, yeah. So see, this is the graph, and this is the straight line going through all those points, and the things has been displayed up. Right, that's a regression line passing through this all, and getting it done. Okay. Right now, let's come to the next thing, logistic regression. We'll complete this today. One I would be giving you, and the other you have to do on your own, right? So now I'm going to give you an understanding, like you will be making two projects based on iris feature and like iris species feature EDA reports you have to like make it there, and you'll be making Titanic survival prediction one, right? I'll be giving you how you can perform EDA reports, right? But not giving you the exact project, right? So you have to make it, but I'll be building one something over there, right? So fine, with the logistic regression, files have been uploaded, right? So let's bring the iris. So like sepal length, sepal width, petal length, petal width, and the species. I think we have discussed even these things, right? So let's quickly come up to the things, right? Not wasting up much time here. So we have sepal length, sepal width, petal length, petal width. These are the four features on basis of which we are going to predict. What we are going to predict on the basis of this? Anyone could say what we have to predict on the basis of this?
Species.
Yeah, species. So on the basis of this all features, we have to predict the species, right? That's the only thing. So always remember this important thing that in machine learning process, right? And use actually the short terms. So in machine learning process, like that. The very first thing always for your project, this is to be there, like the indexings and all, right? How you going to make your project? The very first thing is to define the objective. Okay, I think you have got something in your group, like the KGP students, right? You have got in your group like to submit a project, something like one format is there. Don't go with that, right? I personally said don't go with that. That is exactly I saw, like it was kind of a school project what we do. Not like that. Okay, don't go with those things. Like 64 page project was there. What project it was? Don't go with that. Go with simple things. So I'm giving you what are you have to do basically. So define the objective. Write the what data you are gathering on. Right. Okay. Then you go with the data exploration. Just show that how you are exploring the data set, what new things you are finding up there, right? Then you have to build a model, and then you have to evaluate that model. Evaluation means that you have to find the accuracy, precision, and all those things, right? That's all, right? And at last, after evaluating, you will be finding the prediction. You will be going for the prediction process. That's it. These three things are like included, or you say these are the most important thing when you go for any machine learning process. Important things, right? Is to be kept in the mind. And the important features, important packages, what you have to use is I'm giving you like what you can use is I'm writing line by line whatever we have read till now. Very first, starting with the first thing, you can use math, you can use time. Time is not very important, but for machine learning, I think for these two things you don't require even the math also. You require the simply like to show the equations what basically you are using, right? So you can write from. I'm not writing some simply and all those things, importing everything, right? You can write that this way. What is being left? Pandas, matplotlib, seaborn, numpy, simpy. Uh, what I'm missing out there? One such thing is there missing. That one is simply. Which package I'm missing? All right, left it. So next is like these two things are very important from sklearn. Always when you start linear regression or logistic regression, just write up these things. Okay, and also like with the metrics, because when it is in the case of finding the accuracy, you have to use the metrics. You can go with the classification reports, you can go with the accuracy, you can go with the confusion matrix. To understand what are these things, right? And one more is there, like you have to use the model selection process, like when you are going for evaluating a model, when you're going to give some features to your model. In that case, you have to go through that model selection, basically it's called as, right? So from sklearn.model selection, you have to find out the train and test selection, right? So you have to import that train and test data set, basically. From sklearn.model underscore selection, import import is a train underscore test underscore split. So these are the features. What is they cannot import accuracy from sklearn.metrics. Why? Report username package not found. Hmm. Okay, so I think it should be score. Yeah. So use all these features, right? That you are using all the modules and packages and all, right? That's the very first thing. Fine. So what is accuracy score? Just nothing but the ratio of the number of correct predictions to the number of total predictions. That is an accuracy score, basically. Okay. Confusion. All right. So let's see. I'm just giving a definition of whatever I have used. So accuracy score, what I said, the ratio of the number of correct predictions to the total number of predictions. That is called as an accuracy score. One more thing is there, confusion. That is also important. Student have confusion regarding this confusion matrix. This creates a lot of confusion basically. What actually it tells is, right? So when you go for understanding this confusion matrix, it's very easy, like, but still it creates a basic confusions in your mind, right? So what it actually does, it gives you a table kind of thing, right? That consists of reports, right? To understand the true positives, true negatives, and all those things, right? So binary four values you'll be getting either one and zeros, right? That is basically a confusion matrix. Okay. So it's a special, or you say specific table that allows you to find the visualization of performance of an algorithm, right? That is being given in a confusion matrix. It would be a kind of a 4 by 4. Many a times it goes with a 4 by 4 thing, otherwise it would be various features. Okay, Fine. So confusion matrix, you can say, is a kind of a table which gives you the values or a visualization to a binary classification. Okay. So I'll say it as table used for binary classification. And when I say binary classification, this binary classification has four types. Now, what are those types? The very first is true negatives. Now, what is this? True negatives. That is correctly predicted negatives. Now you're going to actually get confused. Next, we have true positives. Now, this gives you correctly predicted positives. That is correctly predicted once. Similar to those, you have false and all, right? You write it as 3 or 4, whatever you want. So this is false negative and this is false positive. Right? So false negative gives incorrectly predicted things and this incorrectly. So that is the things behind. Okay, I should write it better. Okay, so binary classification are four types. So you'll be getting a graph of this all things. Right? Now that means, like, let me give you a clear idea what exactly it is. So let's say I'm giving you an idea, right? You have to make this project. So let's say this is a data and I'm reshaping this in some -1 to 1 format. Alright, so this is my x and y. I'll show you my x. This is my x, 0 to 9, right? And this is my y, 0 0 0 0 1 1 1 1, right? So what I have to do is I want to create a model and train this feature. That is my purpose, to create a model and train. What to train? That whenever I am going to create or find the values of x and y at the beginning, all this 0 0 0 1 1 1 1. Okay. So what I'm going to do is I'll say this is like one model, this is model, right? And not passing any kind of regressions and all, just fitting the values. So x and y, model dot fix x and y. Okay, so not given any name. So let's say if we go with the logistic one, not going with the linear. So model equals to logistic regression. Okay, and let's fit it. Right, done. Okay, now fitting process has been completed. Now let's say, like, what are the classes of this model? 0 and 1. Only the 0 and the 1, right? What is the intercept and the values, like coefficient? These are the coefficient and the values. Now here what happens, we find the probability, basically that's the evaluation step. Evaluation your model, right? So I'll say model dot predict. So what to predict? Predict the probabilities from which the x. So these are the values, like from 0.98 it is 0.1, 0.95, and the values have been given, right? So what exactly you have to do is, you don't have to find for the probabilities and all, right? You have to predict the values basically. So predict the values of x, that's it. So we are getting the same things, right? 0, 0, 0, 0, 1, 1, 1, 1. See, if you compare the values of x and y, are we getting the same things, right? Are we getting the same things? Let's see. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Obviously, right? Now, so what is the score of our model? 100%, right? So you, when you have less data, it obviously it is going to be 100%, right? So what is the confusion matrix of this y versus the model dot predict the x? What you can see, 4006. What I say, this is true negative, true positive, false negative, false positive. That means that in your data set, in the y, you had 4 zeros and you have predicted the 4 zeros correctly. No incorrect predictions, 0 incorrect predictions. Okay, right? And in the ones, you were having 6 ones and you have predicted the correctly 6 ones, right? So no incorrect predictions. That is, if you have incorrect things, you will be getting it here, right? So we'll be taking it accordingly. That is the thing, right? That is how we make a confusion matrix basically. Okay, that is how it is being plotted. Let's say Cm is equals to, let's plot this confusion matrix. Subplots IM show means image showing. Okay, so we are plotting an image, that's being a graph basically, that's it, nothing is there. So let's set the text means, right? You know, the in the graph, when you get 0, 1, 2, 3, whatever the values you want, you can set it accordingly. And let's say I only want 0 and 1. Okay, and I say my tick labels to be predicted zeros, and predicted ones. Okay, let's say actual zeros, actual ones. Okay, and like after setting the sets, what do we do? Let's say that we'll set the y limits. Because we have data from to there, so let's make it from 0.5. Okay. Now we'll make boxes for the plottings, like for the 1 box, 2 box, 3 box, and 4 box, right? 4 boxes will be there. So we'll make it for I in range of 2, and for the range in 2, right? We'll say ax dot text j and I confusion matrix I and j, and we can say the center values to be, right, text positions in the center. Just understand that what is being written, that's it. I think white would work. In the VCR we have orange and yellows. Okay, so fine. Let's see black, what black does. Yeah, fine, it's okay. So better than VCR, I think it's cool one. Right, so what you see here, it is 4 actual zeros were there and predicted zeros are, what is there? Yeah, predicted zeros are also 4. Okay, actual zeros were fair and predicted zeros are also 4. Actual ones were 6 and predicted ones are also 6. Okay, that's the thing. So that is how you do the like findings and all with this all. Okay, now what you have to do is, when you go with the data sets, right, when you go with the data sets, what you have to do is you have to find out the EDA report. EDA report means exploratory data analysis, right? So you have to go with the data analysis part. Data analysis is very clear, right? Select any features and find out the things respectively. Let's say this is figure, and then I go with the fixed size. So give an objective and then go with the plottings. So like you are going to find the regression line, like you want to find the best fit line for all the species. So what you can do is, sepal length, petal length, whatever you want, right? See, right? So best fit line over there for that, right? But in the same case, like if you want something for the species, so you can write for like various species if you want. So you can write the species name for going up the things, and you'll be getting individual separate lines for that. That is being called as a data analysis part, right? So you'll have to go through all these things basically to do a lot. Okay, I'm giving you just like now the things, right? So we are going to train our model now. Same you have to do for the Titanic dataset. So IBM students, you will be getting how to do with the trainings and all with the IBM Titanic dataset tomorrow. And the KGP students, right, those who have classes from 4 p.m. Your course ends today, right? We'll be completing this up right now. So now we are going to select our features. So let's say in the iris, what are going to be our features? All after dropping the species. Whatever there is left after dropping the species is going to be our features. So this is going to be our x. What is that? No, not like this. If I say only the drop the species, that's all. Species not found. In the data for prices, and this is not found. X is 1 or x is 0. I think I have to load it again. Okay, let's write up the things. And my y will be only the species I want to predict, right? This will be my x and y, my data set, right? So now I'll be making the training and the testing data set. So what happens in the training and testing data set? Let's say that if you have something as, let make first clear. What is that? Let's say that you have 20 things, right? So what you do is, in the training and testing dataset, I'll be giving some random state testing size and all. What you do is, you select some features from here, like some part. Okay, you will not be able to understand it like this. So what you do is, basically, you will select some features, right? No field set out, etc. Okay. So with the sum features, what you are going to do, you are going to say that these are the training features. You will be giving all these things, right? On the basis of this data set, now you will be selecting some part of this data, and you will be giving only these values when you are going to test. You will be giving these values, and you are going to see whether this output comes exactly as this or not, right? That is called as testing. So with the same data set, you are going to do testing and also the training, right? That's at the point. So training, testing data, split you have to do. And what you have to split? X and Y. Now it depends on you. You give the test size or the training size, whatever you want. So I give the test size from out of 100 as 0.33. Like from out of 1, I give 0.33, 33%. And random state, that means I will be only going for one loop, right? That is, for one time I'll be training my data set. That's it. Okay. And that's it, done. Now see, like if you see the df iris dot sorry sorry the shape, that is 150 over 5, right? But if I see the length of this x train, that is 100. So we are training with 100 data. Got it? Right? Okay. So let's say this is the model of iris, and I just write the things. Done. Predictions. What is that? Wrong spelling. So these are the predictions particularly, right? 50 values has been taken up there. Okay, these are the predictions. Now we'll see the classification report. 'Precision is 1.0, nice. F1 score is 97%, that's nice. Setosa category is given like 1, Virginica is 0.93, okay. And where is Versicolor? Okay. So Versicolor is 1.95, and that's nice. What is the score? Let's see the score. 97%. Nice. So 97.33% is the score for our model predictions, right? So let's find the coefficients. What is that? Intercept. Right. So intercept has been given, coefficient has been given, right? So now we can easily write that if we want to predict any features, if I say that I want to predict something like, let's say the points 4.7, or petal length as 4.7, petal width as let's say 5.6, sepal length let's take 9.7, sepal width let's take 3.4. So what is the species? This is Virginica, right? That is being given to you, right? That is how we. So confusion matrix. So you can make confusion matrix of this. So what should I write in place of confusion matrix inside that? What should I write? Yep. What should I write? Quick answer. So this is going to be the confusion matrix, the values, right? So if I make a confusion matrix of this, like plotting of this confusion matrix, so I'll find it to be so what I'm getting basically is 014, yeah. So 17 actual zeros were there, and this all values. Okay, I have to even write up this here. That is, one is giving you the versicolor. Sorry, uh, remove of the labels. Let's say. And, somewhere. Yeah, okay, fine. What you're getting is exactly like 17 species. Like 3 species are there: 17, 18, and 14. If you add up like 17 plus 18 plus 14, what's the total value? 49, right? Why? Because 49 correctly things has been one wrong thing has been there, right? That is, what is the middle species there out? What is the Setosa versicolor? And if you see the classification report, you will find some errors somewhere. Like in the Setosa, we are getting everything 111. The Virginica, we are getting 93, 197, right? And Versicolor, we are getting 1, right? 95, 97. So that I think versicolor, yeah, versicolor. So versicolor, we have got one wrong value for the Y prediction. If you get for the Y predictions, Y test, these are the Y test, right? So let's compare this. 77 is false. 77 number is false, right? So what is there in the Y test of 77? Versicolor, okay, right? So versicolor is one wrong prediction. Otherwise, everything is correct. All right. So like that, you can predict up your values, and you can make even much more things, right? So IBM students will be discussing Titanic tomorrow, and for the other, this is completed. For the same, you have to do for the Titanic. You have to go for survival. You have to find the survival of the species. Sorry, the survival of the passengers there. Okay, so you can load the data set like. Alright, so you have passenger ID, you have survived, you have P class, name, sex, age, sibling, parent, children's, ticket, fare, and a lot of columns between them embarked while what is this Wikipedia ID, whatever it is, name at Wikipedia, age wiki, and all. Okay, board and destination, live board, body, class. Many things are there basically, right? So I prefer not to go with this, but you can take it for like exploring. Let's see what are the columns basically. All right, lot of things are there. Forget that. You just write sns dot load a data set of a Titanic. That's it. That would be done, right? So with this data set, you go like going with it, and you have to go for the survival. Find the survival. Okay. Use dummy values for converting P class, X, and whatever you can do, right? Okay. I think that's fine.